Hi guys, today I will talk about three different iteration techniques: substitution, partial fractions, and iteration by parts. So before you start to apply a technique, so make sure that you do some mental work to see if it's a good strategy. Hopefully, practice will help you recognize which technique is going to work. So these are some common tips. So for substitution, so usually one root is the derivative of the other root, or when you let u to be an expression, your integrand becomes simpler. With partial fractions, so I would say these are easy to recognize. So usually you got a polynomial in the denominator which you need to factorize. So integration by parts. So you need to see whether one root can be differentiated and the other root can be integrated. For the first example, if you do some mental work here, if you let u to be square root of x, when you differentiate u, you get 1 over 2 root x, which is the other root here. So the other root would be 1 over root x. So now you make the x the subject, and then you substitute back in. You can see that root x and root x will cancel out. So in this case, substitution will work. In the second example, so using substitution again. So if you let u to be this root here in the denominator, usually you ignore the power. And then you find the u dx. So you get this function here, which you have on the numerator. I will not go to the full iteration here. Hopefully you can see if you make the x a subject, substitute into here, the x plus 1 and x plus 1 will cancel out. So now we move on to trig function. So you can only integrate a trig function with power 1 directly. If the power is not 1, then you need to do some basically manipulation here. So you got cos to power 3 up to x over here. So what you can do is you can split cos power 3 into cos multiplied by cos square. So you want both sine and cosine because they are derivative of one another. So for cos square, you want to turn that into 1 times y sine square. And then you can use substitution. So you let u to be basically sine of 2x here. So when you find the u, the x, you will get 2 cosine of x. And as you can see from here, the other root is cosine of x. So when you rearrange, make the x a subject, cosine 2x will cancel out with 1 over cosine 2x. The next example. So in this case, both powers are even. So you need to use another technique. So this is when trig identities are useful. So we know that sine x cos x is equal to sine 2x over 2. But then you got square, so you just have to square the whole thing. And then you use another trig identity because you still got power 2 here, which you cannot integrate. So you use another trig identity to turn the trig function into power 1. So now you can integrate it. So this one is the harder example of substitution. So firstly, obviously it's not integration by partial fraction here. Integration by parts you can try. We'll talk about that later. So with substitution, if you let u to be 1 plus 2x squared and then you find u dx, and then make dx the subject. Now, you got x power 3 in the numerator. You can split that up into x squared times x. You can make x squared the subject from this equation here. So this term is the x squared. So you got x squared times x, and then the x is the u over 4x. So you can, I think I missed the constant over here. So that should say 4x here. So now you can cancel out the x, and then you simplify the expression here. And don't forget I missed the 4 somewhere here. So that should be 1 over 8, I think. So now you need to split this up into 2 terms. So now you can integrate it. If you try integration by parts, and you let u to be 1 over root of 1 plus 2x squared, you can find the u dx. And if you let v prime to be x cubed, you can also integrate that. But if you start to apply the expression for integration by parts, you can see that this one become more complicated, which you cannot integrate. Okay, so another example here. So remember, we focus on 3 techniques. Obviously, this one is not integration by using partial fraction. I hope that's obvious. And you have 2 different functions, exponential and trig. Substitution will not work because it doesn't matter what you do, you will not cancel any term out. So in this case, we will try integration by parts. So if we let u to be e power negative 2x, and then you find your the u dx, and then you let the v dx to be cos 2x plus 3, and then you find your v here. So now you apply the rule for integration by parts like this. So this term is fine. And then for the second term, again, this is similar to the problem we had previously. You still got the product between exponential and trig, so you cannot integrate that directly. So now you need to use integration by parts one more time. Okay, so you let u to be e power negative 2x, and then you let the v dx to be sine 2x plus 3, and then you apply the rule, you will get to here. So this time you need to use both equation. So the one that you got when you integrated once, and then the second equation here. So as you can see from here, so this term is exactly that term, basically. Okay. So you substitute 1 into 2, and then you end up with this expression here. Because you only want integral of e power negative 2x times cos 2x plus 3, all you need to do is divide it by 2. And make sure that actually, make sure you have the c as well when you integrate it. Okay, just the last 2 examples here. So in the denominator, you got a polynomial. So you can try to, actually in this case, because the numerator has the same degree as the denominator, so you need to basically divide. You can either use long division or you can use some techniques like this, because you want to cancel the denominator out. So in the numerator, so you want basically a factor of that. So you look at the leading term here, which is 2x squared. So if I take the 2 out, and then inside I end up with basically what you want to cancel out. Yeah, you put it there. So now you do the sum. That's got 2x squared and then 6x. But initially I only got 3x, so you need to take away 3x. So with a constant 2 times 2 is 4, but I only had 2, so that's why I have to take away 2 here. So now you can split that up into 2 separate terms. And for this first term, you can cancel these 2 out, so you end up with 2. So the second term would just be that. So this time you can use partial fraction for the second terms. Okay. The last example. So this one is a polynomial. However, if you try to factorize it, it will not work. You can test that by working at a discriminant. In this case, discriminant is less than 0, so you cannot factorize. If that's the case, then try to complete the square like this. And then up to this point, you can integrate it.